I'm going to be talking to Dr. Kent Moore, who's a professor of atmospheric physics at the University of Toronto, about the role of atmospheric rivers in the recent BC flooding. So welcome to the interview, Kent.
Hello, welcome.
So what exactly is an atmospheric river?
Well, that's a very interesting question, and it's one which scientists have understood these things for quite a while now. But I guess in the popular, press in the domain, it's not known. So, what an atmospheric river is it's a really long ribbon of moisture in the atmosphere. Generally, they can extend 2,000, 3,000 kilometers, and essentially what happens is that, especially in the fall and winter off of the west coast of North America, one gets very, very deep cyclones, which are regions of low pressure. And around a region of low pressure, the winds are counterclockwise. And what happens is these low pressure systems just bring moisture up from, let's say, Hawaii, straight up towards the west coast of North America. They're sometimes called Pineapple Express because, again, they're bringing moisture from the tropics up to the north, and they carry huge amounts of water vapor. They can carry as much water vapor as there is water in the Amazon River. So they're huge, and they are rivers. They're essentially rivers in the sky. This kind of cone of water vapor coming up northwards. And of course, when they get to higher latitudes and also the topography of the west coast, a lot of the water vapor in these rivers rains out, and that's in fact what happened just this week in BC.
Now, I understand that when there's a weather event, that they are rated on a scale of 1 to 5, 1 being the weakest, 5 being the most intense. And what the one we had a few days ago was a 5. Is that correct?
Yes, correct. Yeah.
And how often do we have rainfall that's rated at a 5 caused by these atmospheric rivers? Is that a fairly common occurrence, or is it a fairly rare occurrence?
Well, of course, so a lot again in the fall and early winter in BC and the west coast, a lot of your rainfall events are these rivers. And again, there are some weak ones and there are some strong ones. So the ones that are really strong, of course, occur quite infrequently. You may get one very intense storm every winter. This one was clearly, it was off the charts, frankly, as far as just you think about that you were getting, in some places they were getting a month's worth of precipitation in a given day. So those events are really quite rare. But again, every winter you probably get, one kind of really heavy rainfall event, which would be associated with one of these rivers. So this one is really rare, but most of your rain in the winter and fall comes from these sorts of events.
Now, I understand that climate change can affect the atmospheric rivers, and as the atmosphere warms up, does it allow the atmospheric river to hold more water? How does climate change affect an atmospheric river?
Yeah, so that's a really good point. So when we warm the atmosphere up, one of the things that we do is we allow the atmosphere to hold more water vapor. So that's just a function of temperature. The warmer the temperature, the higher the amount of water vapor you can have in the atmosphere. So without any changes to the structure of the low pressure systems, which are the things that are driving these rivers, a warmer atmosphere will have more water vapor in it. Okay. Now, clearly, a more intense storm will also have more water vapor associated with it. But the point about climate change is that even if we're not changing the intensity of the storms, by the nature of the fact that we're warming the atmosphere up, those storms will have essentially more water vapor associated with them. And that's the sort of mechanism that we think is responsible for the increase in precipitation that one is seeing. A number of years ago, I was involved in a study of an ice core from Mount Logan in northern Yukon. And it turns out that Mount Logan gets most of its snowfall from atmospheric rivers. And we had essentially a record, almost 200-year record of snowfall on Mount Logan. And from the 1850s onwards, the amount of snow that was falling every year on Mount Logan was increasing. And we attributed that to the fact that the atmosphere is just getting warmer and it can hold more water vapor. So there are long-term records that show an increase in the intensity of these rivers.
Now, there's a 2018 study that caught my attention, and I think the study concluded that atmospheric rivers that reach the BC coast can become, and this is due to climate change, up to 25% wider, 25% longer, and overall 50% more intense than before. That doesn't bode well for the coming years.
No, and again, that's again a consequence of the fact that they're warming the planet up, and the hydrological cycle is just becoming more intense. So yeah, I think the thing about climate change is that we have warmed the planet up by about 1 degree since 1900, and with it has come a plethora of extremities. One of them are these extreme rainfall events. So under the best case scenario, we're going to warm the planet by another 0.5 degree. That's, I think, probably unrealistic, maybe more like 1 or maybe 1.5 degrees more. So whatever we're seeing now, right, is going to become more intense in the future. And that was really the point of this paper. They were using a climate model to look into the future and see how these atmospheric rivers were going to behave. And so, yeah, it doesn't bode well, because the extremes we're seeing today will become the norm, close to the norms. And the new extremes will even be more extreme. So I think we really have to sort of reassess, first of all, infrastructure. I think in BC, people are discouraged from building on floodplains. And one of the problems with this whole climate change is we're moving the goalposts. So what was a floodplain 50 years ago is not a floodplain today. And I think some of the consequences that we're seeing, in BC are the fact that, the nature of the extreme, hydrological events we're getting is just becoming more extreme. And what we thought in the past was okay is no longer the case.
Final question, Kent. So you had described the event of a few days ago as fairly rare. How much more? How likely is it that it will not be rare anymore, and that we will get these? Will they become an annual thing? Will we get a number of them every year? What do we have any sense of that?
Yeah, so that's a really hard question to answer, because by definition, we're talking about extreme events. And even if the atmosphere hadn't warmed up, this event probably would have been extreme, not as extreme as it was, but still, on the outliers. So it's really hard to predict. I think one way we like to think about extreme events is a return time. So we can talk about a storm that happens once every century. And this is an event that probably is like a 1 in a century event, or 1 in 50-year event. And in the future, it may become a 1 in a 10-year event, right? So essentially, because the extremes are getting more extreme, the return time for any given intensity of the event is getting shorter. So I don't have an answer to that question, but my expectation is they're not going to become annual events, but they're going to become, more common. But the thing is that even the annual events are becoming more extreme, right? So we won't, we wouldn't see every year the level of flooding that we're seeing today or whatever, but the events are going to become more extreme. So again, we're going to get more rain falling. And again, one of the problems, of course, is that, in an urban setting where, we're paving over, wetlands and things to produce parking lots and condos and things. And so whenever we do that, we reduce the ability of the land surface to absorb some of that water, and just more of it runs off. I think droughts in the summer in BC are going to also exacerbate these rainfall events, because we're losing vegetation. Obviously cutting of trees reduces vegetation. And so when you do that, the mountain slopes just can't hold as much water, and it just runs off. So I think we're kind of amplifying some of these things. So I think we're in for a rocky future, but thankfully these events will still be extreme in the future, but they'll be more common than they have been in the past.
Kent, thank you very much for this. You've provided some eye-opening and sobering information. Really appreciate it.
Thank you. It's my pleasure.